everyone, welcome back to Learning with Haneen. In today's video, we're going to be finishing the January 2025 Geometry Regents by going over the written response questions in parts 2, 3, and 4. So that further ado, let's begin. And if you have any questions, please feel free to comment them down below, and good luck on your exam. So question number 25 says, in the diagram below, quadrilateral BCDE maps onto quadrilateral JKLM using a sequence of rigid motions. Determine and state the degree measure of angle D. So, first things we know is that the quadrilaterals correspond to each other. What that means is that if I have quadrilateral BCDE, that means JKLM corresponds to it. So angle B is congruent to angle J, angle C is congruent to angle K, angle D is congruent to L, and angle E is congruent to M. So right here, we need to find the measure of angle D. So I know angle J and angle B are congruent. That means angle B is 117 degrees. And I know that angle C is congruent to angle K, and since angle K is 70 degrees, I know that C is also going to be 70 degrees. Now, how do I find out the measurement of angle D? So this entire quadrilateral has a degree measure of 360 degrees. So what I'm going to do is I'm going to do angle B plus angle C plus angle D plus angle E is equal to 360 degrees. So I know angle B is 117, angle C is 70, angle D is unknown, and angle E, which is 91 degrees and equal to 360. So when I add all of that up together, I'm going to get 278 degrees plus angle D equals to 360. Subtract 278 on both sides. Angle D is going to equal 82 degrees, and that is your final angle. So the measure of angle D is 82 degrees. That is your final answer for question number 25. So very straightforward. What you need to know for this question is the total measurement of the interior of the shape, and how the fact that when you have quadrilaterals that are, or any shape that are mapped onto each other, their angles are going to correspond to each other. Question number 26 is a construction question. So it says, given a line segments AB below, use a compass and straight edge to construct a segment that is 1/4 of AB. So I'm going to show you what this construction looks like on this here. So I'm going to draw a straight line for you, and that's going to be line AB. So here is going to be my, so right here is going to be my A, and over here is going to be my B. Now I'm going to take my compass, and in order to construct the 1/4, what I want to do first is I'm going to perform a perpendicular bisector to split my line into two congruent segments. So I'm going to first perform a perpendicular bisector. So I'm going to extend it greater than a half of my line approximately, and I'm going to draw my arc, and then I'm going to move it to point B and do the same thing on the other side. I'm going to move it over point B, make sure that your distances are the same, and draw the other arc. Okay, now that you've drawn the other arc, what you're going to do is you're going to draw a straight line down where your arcs are. So it's going to be a rough line, but it's going to be, your guys are going to be much more precise on the test. And right here where they intersect, and then we're going to draw a straight line downwards through my points, not the straightest line. Let's do that again. Okay, let's get a line. I'm gonna draw a straight line. There it is, much cleaner. My straight line, and this is going to be, we can call this point M, right? And then what I'm gonna do is I'm gonna perform another perpendicular bisector from A to M to make it a fourth. So what I'm gonna do is I'm gonna take my compass once again. Take my compass. Let's reset my compass, rotate it around. So I'm going to place my compass at point A. Just going to fix my compass. And I'm going to try to reset it to its original shape. Okay, so here it is at its original shape. Oh, sorry. Oh, no, don't. Okay, so again, what I'm going to do is I'm going to take my compass, I'm going to extend it almost halfway through the distance of A and M, and I'm going to draw a perpendicular bisector. Okay, and I'm going to flip it with my compass, and I'm going to do it, place it on point M. Again, this is not going to be as precise as you are, but it's just showing the overall steps. And then I'm going to draw another perpendicular bisector, and then I'm going to remove my compass, and then I'm going to draw, so this is my new points. This is going to be the fourth that I need. I'm going to draw a straight line down to my 2 points, to my points right here, and we can call this point C, and this is going to be your fourth. So this is going to be right here, the second perpendicular bisector right here is a fourth of AB. So what I did, again, to reiterate, I did a perpendicular bisector of line AB to split it into half to 2 congruent segments, and then I made my new segment to be AM, and then AM I performed another perpendicular bisector, and from there I got a fourth of AB. So this is how you would perform that question on the January 2025 Regents. Question number 27 says, a dog sees a bird in a tree. The angle of elevation from the dog's eyes to the bird is 36 degrees and as modeled below. The dog is 18.5 feet away from the base of the tree, and his eyes are 2.5 feet above the ground. Determine and state how high the bird is above the ground to the nearest foot. So what do I know? I know that it's an angle of elevation at 36 degrees, and I know the dog is 18.5 feet away from the base of the tree. So from the dog to the base of the tree, it's going to be 18.5 feet away. And I know that his eyes are 2.5 feet above the ground. So right here, the distance between where the dog is looking up and where he is on the ground is 2.5 feet. And I'm trying to determine how high the bird is above the ground. So my X is going to be right here, the side that is opposite to my angle. So if I recall my SOHCAHTOA, I know that if I have a side that is opposite and a side that is adjacent to my angle, I'm going to use tangent. So I know that I have my adjacent side, right? So I know tan of 360 is equal to, I don't know my opposite side, but I do know my adjacent side of 18.5. And what I'm going to rewrite that as is 18.5 is just simple cross multiplication, tan 36. Please make sure your calculator is in degrees. Very, very, very important. Make sure your calculator is in degrees. And when you put that in your calculator, you're going to get 13.4410367. That's what ends on your calculator. But this is not your final answer because it says how high the bird is above the ground. Remember that the dog's eyes, when they are looking at the bird, they are 2.5 feet above the ground. That means that this 13.441036677 is not the total distance that the dog is looking upward to the bird. So what I'm going to do is I'm going to take my 13.441036677 and I'm going to add to it 2.5 feet that the dog's eyes are above the ground, and I'm going to get an answer of 15.941036677. Rounded to the nearest foot is going to be 16 feet above the ground. Is how high the bird is. Again, the bird is right here. So that is how high the bird is, this distance right here. That is how high the bird is. Question number 28 says, pure silver has a density of 10.5 grams per cubic centimeter. Samantha has a pure silver charm on her necklace in the shape of a sphere. The radius of the charm is 0.5 centimeters. Determine and state the mass of the charm to the nearest tenth of a gram. So, I'm given my density to be 10.5 grams per cubic centimeter. And I know the formula for density is D equals M over V, mass over volume. So I need to find my mass. So that is X. So what do I need to do? I need to first find my volume. I can find my volume because they tell me that it's in the shape of a sphere. And I know that my radius is 0.5 centimeters. So I'm going to be using the formula of a sphere for the volume, which is V equals 4/3 pi r cubed. So when I put that in, I have V equals 4/3 pi, my r is 0.5 cubed, and what I get that as to be 1/6 pi. Okay, I'm going to keep my pi for now until the end. Do not change your pi. Do not convert it and use 3.14. Keep your pi until the end. So solve all the math, but keep your pi the same. Now I need to find my mass. So I'm going to plug this into my density formula. I know my density is 10.5 grams per cubic centimeter. It's equal to my mass, which is unknown, so that's going to be my X, over my volume of 1/6 pi. So again, simple cross multiplication is going to be 10.5 times 1/6 pi is going to be the value of my mass, and my mass is going to be equal to 5.4977, which the nearest tenth is going to be 5.5 grams. Do not forget your unit. So the mass of the charm is equal to 5.5 grams. Okay? Question 29 says, in triangle ABC below, line segment DE is drawn such that AD is 4, DB is 8, AE is 3, and EC is 6. So, explain why triangle ADE, so the small triangle right here, is similar. This symbol is similarity, okay, to triangle ABC, my bigger triangle, this triangle right here, my big triangle. So explain why. Well, for me, I can see that, first things first, I know that triangle DE, and triangle ABC share angle A. They share angle A. So angle A is congruent to angle A. So I know that this angle is shared among them. It's congruent. And I know also that my triangles, they have proportional sides. And when they create these proportional sides, what I see is, and they create these proportional sides, and what I see is sides that are I have side 3 to 9, so I have AE is 3 to AC is 9, and I have AD, which is 4 to AB, which is 12. And when I set these ratios equal to each other, so I have AE to AC, and I have AD to AB, what I end up having is 3/9 to 4/12, and I ending up having a ratio of 1/3 to 1/3. So I know that these sides are proportional. So I know that I have this side is proportional to this side, which is, well, the sides are proportional. So I know that I have an angle that is the same, and I have proportional sides. So according to side angle side similarity, triangles ADE is similar to triangle ABC because angle A is congruent to angle A, and the ratio of the sides is the same. And we can demonstrate that by showing that AE over AC is equal to AD over AB, which equals to 3/9 over 4/12, which equals to 1/3, which equals to 1/3. So this part is this part, and it's this part, which means that the sides are proportional. And because the sides are proportional, two sides are proportional, and because the angle is congruent, I can prove that triangle ADE is similar to triangle ABC because, again, angle A is congruent to angle A, and the ratio of the sides is the same, therefore meaning that the sides are proportional. There is other ways to solve this, but this is the first things that I noticed. I noticed that there's a shared angle and two sides are proportional. 3 is proportional to the 9, and 4 is proportional to the 12, and it's 1/3 to 1/3, so they are proportional. The side AE to AC is proportional to side AD to AB. Question number 30 says, encircle E below, tangent PA and secant PBC are drawn. If PB is 9 and BC is 16, determine and state the length of PA. So I know that PB is 9, BC is 16, and I need to find the length of A and PA. And I'm told that PA is a tangent line and PBC is a secant line. So what I'm going to use, I'm going to use the formula of the whole times the external of my secant. So the whole secant times the external of the secant is equal to the tangent line, tangent squared. Okay? So the whole length is 25 of my secant. So this side is my secant. Okay? So the whole side is 25. The external is this portion right here that is outside the circle is 9. and is going to equal to my tangent, but I noted as x squared. So 25 times 9 is 225, is equal to x squared, and to get to isolate x, I would square root. So I end up having x equals 15. So the length of PA is 15. Okay, question 30. Question 31 says, in a right triangle, sine 4x plus 3 equals cosine of 2x minus 9. Determine and state the value of x. So what I want you guys to recall is that the sine and cosine of an angle, a sine and cosine in a triangle, they're equal to 90 degrees, but they're also equal to one another. Okay, so say for example, I have a triangle. This might be a little bit away from the problem, but I just wanted to mention this. So if say I have triangle ABC, okay, and I'm given angle B of, let's say, 24. I'm given the sides are, let me see, I'm trying to remember a triple. What is it? 3, 4, 5. Yeah, 3, 4, 5 triangle. So I have a 3, 4, 5 triangle. So sine of angle B is equal to 3 over 5. Sine of angle B, yes. Cosine of angle A, right? If I do cosine of angle A, and say that I don't have the measurement of angle B, cosine of angle A is also 3/5. So cosine and sine of specific angles are going to be equal to each other. If I say cosine of angle B, that is sine of angle A. So remember, sine and cosine equal 90, and sine of an angle and cosine of another angle are equal. So that's how they set it up. Sine of 4x plus 3 is equal to cosine of 2x minus 9. But I need to determine and state the value of x. Do not set them equal to each other and solve. You must set them equal to 90. So what you're going to do is you're going to do 4x plus 3 plus 2x minus 9 is equal to 90. And you're just going to solve. Normal algebra 1. So we have 6x minus 6 equals 90. Add 6 on both sides. 6x equals 96 divided by 6. X equals 16. So that is your value of x. So again, sine and a cosine of certain angles, like as I showed you here, sine of angle B is 3/5. Cosine of angle A is 3/5. So sine of an angle and cosine of an angle are congruent. They're equal to each other. Sine and cosine together, their sum is 90 degrees. Okay, because they need to make up, because if I have a right angle that is 90 degrees, I know that my sine and my cosine have to equal to 90 in order to create a triangle that is 180 degrees. We're now on to part 3. Question number 32 says, modeled by right triangles below, a surveyor S is taking land measurements using cabin C, a boulder B, and a tree T at fixed points of reference. The cabin, boulder, and tree are collinear. The surveyor is 917 meters from the cabin, 1,048 meters from the boulder, and 1,425 meters from the tree. Determine and state to the nearest degree the measure of angle BST. So they want angle BST, which I'm going to know as it right here with angle X. So what am I given? I'm given the please use the diagram. Please use the diagram. So I have my triangles. I have 3 triangles. I have triangle 1, 2, and the big triangle, triangle number 3. I will let you know you're not going to use triangle number 2 because it doesn't have right angles. And when I'm given a right angle, I know I can use my SOHCAHTOA and I can use my trigonometry. So I need to find the measurement of angle BST. Well, I can determine the value of angle. I'm going to scroll down a little bit. I can determine the angles of I can determine the angle, the measure of angle CST, and I can determine the measure of angle CSB. Haneen, how? So, here's what I'm told. I'm told that the surveyor is 917 meters from the cabin, and 1,048 meters from the boulder, and 1,425 meters from the tree. So, I can use, so I know I'm given my, if I focus on triangle number 1, right here. This is triangle number 1. Right here. This is triangle number 1. It's acting a little weird. So this is triangle number 1. Okay? So, I'm given my hypotenuse of 1,048. I am also given, so if I'm trying to determine angle CSB, which is this angle right here, do it in a different color. This angle right here, this is angle CSB. Should be doing that on the other side. So I'm given my hypotenuse of 1,048, and I'm given a side that is adjacent to my angle. So I have an adjacent side of 917 meters. So, if I recall my trigonometry, and I'm given an adjacent and a hypotenuse, if I'm given an adjacent side and a hypotenuse side, I can use my cosine. So, I'm trying to determine the value of my angle. So, I don't know my angle. So, cosine of theta, my angle, is equal to 917 over 1,048. I don't remember what to do. So, when you're trying to determine the value of your angle, you're going to utilize cosine inverse. So I'm going to show you how to get to that on your calculator. So what you're going to do is, in your calculator, you see where it says cosine. So on top of it, it says cosine to the -1. So you're going to hit second cosine. So it's going to say cosine inverse is going to equal to 917 divided by 1,048. You're going to get a value of your angle is equal to 28.95502. Okay? This is in degrees, which is what we need. That's why I always remind you guys, because during the day of your Regents, your calculators are going to be reset. So make sure that, because there's a lot of questions that ask you for degrees, make sure to change your mode, and you'll see that in the first multiple choice video, how to change it. If your calculator is in radians, change that to degrees, because you need to do that for the test. Now, I found the measure of angle CSB. Okay, is my measure right here. Now I want to find the measurement of angle CST. So for CST, again, I'm given a hypotenuse now of 1,425. So my hypotenuse now is 1,425 meters. And I'm examining the big triangle right here. CST, triangle CST. And I'm also given an adjacent side of 917 meters. Again, adjacent to my big angle. So CSB was this angle right here. I'm trying to determine BST, and now I'm finding out CST. So again, similar to what I did to find angle CSB. I'm given a hypotenuse and an adjacent side. I'm going to be using cosine. I'm trying to determine the value of my angle, so I'm going to do cosine inverse again. Going to be of 917 over 1,425. So I put that into my calculator, and I get the measurement of angle CST to equal, so cosine inverse of 917 over 1,425 and I'm going to get a value of 49.9460. Yeah, 0.0. Now, Haneen, why did I find the measurement of those two angles? Well, I'm glad you asked. So, you are told the measurement of those two angles. Now what do you need to do? Well, I need to find the measurement of BST. Well, I know that CST is equal to angle CSB plus angle BST. So what I'm going to do is I'm going to substitute what I determined. So CST is 49.9460. CSB is 28.95502 plus my missing angle BST. I'm going to subtract 28.95502 on both sides. And I'm going to get, I'm going to write it right here, angle BST is equal to 0.991. And if I recall, my question said to the nearest degree, so I know I run out of space here, but you guys would have enough space. So the measure of angle BST is equal to 21 degrees to the nearest degree. So that is your answer. Question number 33. I'm going to have to zoom out for this one. So, a garden bed pictured below is a square prism with a rectangular prism taken out. The inside length of the square prism is 6 feet. The rectangular prism taken out has a width of 2 feet and a length of 4 feet. The diagram below shows the top view of the garden bed with its inside measurements. The garden bed is filled with topsoil to uniform height of 1.25 feet. Determine and state the volume of the topsoil in cubic feet. So I see the shape, I need to determine the volume, right? And they're all squares and rectangles, so I know my formula is just going to be V equals length times width times height. Okay? So I'm going to split up my top view. So I'm going to split it up into this rectangle right here, this rectangle right here, and this rectangle. So I'm going to get rectangle 1, rectangle 2, and rectangle 3. So I need to determine the value of the volume. So volume of 1. So my length, I know, is going to be 4. Right here, this is my length of 1. So it's going to be 4 times my width of 2 feet times my height. Remember, it said that the garden bed is filled with a topsoil to uniform height of 1.25 feet. Okay? When I multiply that together, 4 times 2 times 1. I'm going to get 10. Volume of 3 is going to be the same thing. I'm just going to write volume of 2, and then volume of 3 is going to be the same thing. 4 times 2 times 1.25, I'm going to get 10. Now for rectangle 2. So I have a length of 6. Okay, I have a length of 6. Okay, because this is 2 feet and this is 2 feet. So 2, 2, 2 is 6. And then I have a width of 2 feet. I have a width of 2 feet right here. Because if this is 4 and this entire thing is 6, it's going to be 2. So I'm going to do, I have a length of 6 times a width of 2 times a height of 1.25 to give me 15. And when I add this all together, I have a volume of 35 cubic feet. Okay, and this is the volume of the topsoil. I apologize if I pause in between. I'm just double checking my calculation. Now, it says each bag of topsoil sells for $3.68 and contains 2 cubic feet of topsoil. Determine and state the total cost of the bags of the topsoil that must be purchased to fill the garden. So, I need to first determine the number of bags before I can determine the cost. So I know I have a volume of 35 cubic feet of topsoil, and each bag contains 2 cubic feet. So I need to determine the number of bags. So what I'm going to do is I'm going to do 35 cubic feet divided by 2 cubic feet, and I'm going to get 17.5. People would have the tendency to say, oh, it's going to be 17 bags. No, it has to be 18 bags because I need to fulfill that half. That half will not be fulfilled with the 17. I would rather have more than have less and not enough. So I have 18 bags. Now, I'm going to take these 18 bags and I'm going to multiply them by $3.68 to find the total cost of $66.24. So for 18 bags of topsoil, it will cost $66.24. Okay? Question number 34. We're almost done. So, given triangle ACD with ABC, AED, and line segments BE being parallel to CD, prove AB times AD is equal to AE times AC. So this is a proof question. Everybody's favorite questions on the Geometry Regents. So, proofs. What I do want you guys to do is, even though I'm going to be 100% honest with you guys, coordinate geometry proof, you just need to remember your formulas and how you can prove each shape. For regular proofs, there's a few theorems that you want to remember. Remember your triangle congruency theorems. Remember your triangle similarity theorems. Remember your corresponding sides of similar triangles are proportional. Remember corresponding sides of congruent triangles are congruent. CPCTC. Remember that. Those are really helpful. Remember your properties. Remember your subtraction postulate. Remember your addition postulate. Remember your reflexive property. Remember all of that. I know it's a lot to remember. I know. But it's going to help you guys. And what I want you guys to do, if you're given a proof question, attempt the proof. Even if you only get a few statements down, at least you guys have something. Use the given information because you can get at least a point from the given information. You can sometimes get 2 because some things are very obvious. Others are not very obvious, but that's okay. Attempt and put something for your proofs. Don't just skip the proof question completely. Please, please, please attempt the proof. Please also make sure you attempt the coordinate geometry, because as long as you know your formulas and as long as you know how to prove each shape, whether that's a parallelogram, a rhombus, a square, a rectangle, whatever it is, make sure you guys remember the distinctive factor that distinguishes them from each other. For example, you can't prove a square by proving that it's a rectangle. Okay? There's differentiations between a rectangle and a square. A rectangle, the opposite sides are congruent, whereas for a square, all sides are congruent. So that's something that you guys have to remember. I know we haven't gotten up to the coordinate geometry. I just saw the proof question and I just wanted you guys to, I know it's a lot. There's a lot of theorems, there's a lot of things that you have to remember. But it's more of application. How can I use what I learned in order to apply to the proofs I'm given? Because not every proof is going to look the same. They're not going to look the same, but it's going to be the same procedure to achieve, to prove the statement that you're trying to prove. Okay? So, let's get on to our proof. So, I learned, and many of you learned, the 2-column proof. I have my statements, and I have my reasons, my reasoning. Okay? Or reasons. Now, statement number 1, always put your given. You have triangle ACD with ABC, AED, and BE is parallel to CD. That is given. Okay? Next thing. Without even using my given, I'm given two triangles. I can see triangle ABE and triangle ACD. And they share a common angle of A. So I'm going to say angle A is congruent to angle A. Like that, I got a point. Why? Because of reflexive property. I'm going to spell that wrong. Reflexive property. There's probably not a C in there. Reflexive property. Now 3. I'm going to use my given statement. It tells me that BE is parallel to CD. So when I have two parallel lines, they create a transversal. And when they create this transversal, they create corresponding angles. So they would create, if I extend my line and I get my transversal, what it looks like, angle ABA and angle ACD are corresponding angles. Okay? So angles A B ABE is congruent to angle ACD, but I also get another part of corresponding angles of AEB and ADC. So you can also mention that as well. Angle AED, I know this is starting to look really sloppy, guys, I apologize, is congruent to angle ADC. And my reasoning is that parallel lines cut by transversal creates congruent corresponding angles, or creates, let me rewrite that, guys. Okay, so parallel lines cut by transversal form / creates corresponding congruent corresponding angles. Okay? So now, what have I proven right now? I have proven that angle A is congruent to angle A. I've proven that angle ABE is congruent to angle ACD. And I've proven angle AEB is congruent to angle ADC. So now, I'm trying to prove that AB times AD is equal to AE times AC. Well, what I can do to prove that is I can prove similarity. So, I can state that triangles ABE is similar, please do not mix up your signs, is similar to triangle ACD. Why? Because of angle similarity. Remember your similarity theorems. You have, I'm going to tell them all to you right now. Like I told you, your triangle congruency theorems. I'm going to write them on the side. So for similarity theorems, you have angle similarity, you have side similarity, and you have side similarity. Okay? Now, I've proven both of my triangles are similar because of angle similarity. What does that give me? Well, you know what that gives you it tells you that, let me scroll down a little bit, so zoom out a little bit. It tells you that, so statement number 5. So what I can do with that is, after proving that triangle ABE is similar to triangle ACD, I can prove that AB to AC is equal to AE to AD, because I know that corresponding sides of similar triangles are proportional. Remember your CSSTP. Corresponding sides of similar triangles are in proportion. Okay, now, what do I do after that? You're so close. Number 6. AB times AD is equal to AC times AD, because product of extremes is equal to product of the means. And that is your proof. You've proven that AB times AD is equal to AC. So you see, I was taking my given. I found that angle A is equal to angle A, so I use my reflexive property. And then I found that I'm given parallel lines. When I'm given parallel lines, I create corresponding angles. Those corresponding angles are congruent. So through angle-angle similarity, I proved that triangle ABE and triangle ACD are similar. And then I said that AB to AC is equal to AE to AD, because corresponding sides of similar triangles are proportional. And then, through the product of the means being equal to the product of my extremes, I found and proved that AB times AD is equal to AC times AE. Done. That's it. If you could not get past the angle-angle similarity, that is fine, but at least you attempted it. Please, please, please attempt the proof question. Final question says, triangle PET has vertices with coordinates P is -6, 4, E is 6, 8, and T is -4, -2. Prove PET is a right triangle. So, in order to prove that PET is a right triangle, I know that two sides have to have perpendicular slopes. Okay? So what I'm going to do is, I want to know which sides I want to test. So I'm going to take the coordinate grid that they gave me, and I'm going to plot my triangle. So I have triangle PET. I have -6, 4. Right here is P. And then E is at 6, 8, so right here, that is E. And then T is at -4, 2. Right here. That is T. I'm going to draw my triangle. PET. Now I need to prove that it's a right triangle. To prove it is a right triangle, I'm going to utilize knowing that perpendicular slopes form right angles. So what I'm going to do is, I'm going to test the slope of segment PT and PE. So I'm going to go back to my question. So point P is at -6, 4. E is at 6/8 and T is at -4, -2. I'm going to find the slope of line segment PT. So I'm going to do PT. So I'm going to read it as -2 minus 4 over -4 minus -6. -2 minus 4, -4 minus -6. So I'm going to get -6 over 2 to get -3. Now I'm going to then find the slope of PE. So PE, so I'm going to do 8 minus 4 over 6 minus -6. Please remember your signs. So I have 4 over 12, which is equal to 1/3. So if I have a slope of -3 and 1/3, I know that these are negative reciprocals. And because they're negative reciprocals, that means that the slopes are perpendicular. So what I can say is that triangle PET is a right triangle because the slope of PT is -3 and the slope of PE is 1/3. Because the slopes are negative reciprocals, it means they are perpendicular. And perpendicular slopes form right angles. That's it. So I proved triangle BET is a right triangle because slope of PT was perpendicular to slope of PE, and I know perpendicular slopes form right angles. Okay? That's part 1. Part 2 says, state the coordinates of N, the image of P, after a 180-degree rotation centered at 1, 3. So to recall, point P is -6, 4. So P is -6, 4. I'm doing a rotation of 180, but not at the origin. It's being centered at 1, 3. So in order to find out the image, what I'm going to do first is I'm going to subtract. So I'm just going to write the steps. Subtract 1, 3 from the original point. So I'm going to do -6 minus 1, and I'm going to do 4 minus 3. That's going to give me P prime to be -7, 1. Okay? That's going to be my P prime. -7, 1. And then I'm going to do a 180 rotation. So with a 180 rotation, my X and Y change their signs. So what happens is I'm going to have, after a 180-degree rotation, I'm going to have 7, -1. Okay? X and Y, and I change their signs. So if they're positives, they become negatives. If they're negatives, they become positives. After that, I'm going to add again my center of rotation, which was 1, 3. So I'm going to do 7 plus 1 and -1 plus 3 to get P double prime, or N to be 8, 2. So N is at 8, 2. So that is the point N. So the coordinates of N are 8, 2. Final part. Prove PENT is a rectangle. So I had my original graph. My N is now at 8, 2. So I'm going to graph my N at 8, 2. So 8. Right here. So this is my N. So now my graph looks like this. Looks like a rectangle, but I need to prove it's a rectangle. So how do I prove it's a rectangle? I can prove that the opposite sides are perpendicular. And when the opposite sides are perpendicular, they're gonna create right angles. Okay, so I've already proven that, I've already proven that side PE and PT are perpendicular. Correct? So I've proven that they are perpendicular. Now, what I'm going to do now is I need to prove that EN and TN, I've proven PE and PT are perpendicular, right, with their slopes. Now I need to prove, so I've done PT, PE, I need EN and NT or TN. So I'm going to write them back here again. It's okay if you've already written it once. So I have the slope of PT, and I'm going to recall my point. So PT was negative 6, 4. E was at 6, 8. N is at 8, 2. And T is at negative 4, negative 2. So I have my slope of PT, slope of PE, slope of EN, and the slope of TN. So PT, again, I'm going to do negative 2 minus 4 over negative 4 minus negative 6. That's going to be negative 6 over 2, which is negative 3. PE, I have 8 minus 4 over 6 minus negative 6. I'm going to get 4 over 12, which is 1/3. And then I'm going to have EN, so EN. So I'm going to do 2 minus 8 over 8 minus 6. And I'm going to get negative 6 over 2. And I'm going to get negative 3. And then for TN, I have 2 minus negative 2 over negative 4 minus 8. And I'm going to get 4 over, negative 4 let's see, oh, there it is. I found my mistake. So it's gonna be right here. It's gonna be there. I flipped the way that I wrote my points. So it's going to be 2 minus negative 2, and it's going to be 8 minus negative 4 because it's written as TN. So N is my second point, T is my first point. So I'm going to get 4 over 12, which is 1/3. So I found all my slopes, and they're all negative reciprocals, which means that they create perpendicular lines. So that means that we can say that the slope of PT, PE, EN and TN are negative reciprocals. Such that PT is perpendicular to PE. PE is perpendicular to EN, and TN is perpendicular to PT. TN is perpendicular to PT, and EN is perpendicular to TN. So angle PEN and T are right angles because perpendicular lines form right angles. And that is your proof. So I proved that the slopes were negative reciprocals. From negative reciprocals, I proved that the certain lines were perpendicular to each other. Because they're perpendicular to each other, it means that they form right angles. And a rectangle is a shape where there are 4 right angles, which is proven through finding the slopes and getting perpendicular slopes. And that is the end of the January 2025 Regents examination. Please, if you have any questions, please let me know. I know the video is literally posted on a day before the Regents, but I know that you guys are going to review, you guys are going to do great on the Regents. If you have any questions, I'm going to be making sure that I'm constantly checking on the YouTube channel